For basically our entire lives, we've been sold this idea that life is all about competition, right? It's survival of the fittest, a constant battle. But what if that's only half the story? What if the real secret to thriving, the key to everything, isn't about winning, but about working together? Today, we are diving into the hidden math that shows cooperation isn't just some nice, fuzzy idea, it's an honest-to-goodness evolutionary superpower. Let's get into it. So right off the bat, we run into this huge paradox. You see it everywhere. Lions hunting in perfectly coordinated packs, birds flying in these beautiful, efficient formations. You even see rival companies collaborating on giant open-source projects. I mean, these things seem to completely contradict the whole idea of cutthroat competition. It's a puzzle that for decades has had scientists just scratching their heads.
You know, this very question actually haunted Charles Darwin. His own theory of natural selection seemed to be at odds with the incredible teamwork he was seeing all over the natural world. I mean, if it's really a dog-eat-dog world out there, why do we see these stunning, intricate systems of mutual support? It's a deep question that really makes you rethink our most basic assumptions about how life, and maybe everything else, works.
And this really captures the disconnect perfectly. On one side, you've got that classic image of nature. Brutal, a zero-sum game, red in tooth and claw. But on the other side, you see the reality that scientists are uncovering. A forest isn't just a collection of individual trees fighting for sunlight. It's a community, a collaboration with trees sharing resources through this vast underground fungal internet. And this isn't some rare thing, it's how healthy ecosystems actually function.
Okay, so how do we square this circle? Well, a really groundbreaking new theory says the answer isn't in biology, but in physics. It suggests that cooperation isn't some moral choice. It's not about being selfless. It's a fundamental law of nature, just like gravity. It all comes down to the most efficient use of energy. In other words, it's about thermodynamics.
And that brings us to the core idea here, the I factor. The easiest way to think about it is like a friction tax on any system. It's all the energy that gets wasted on arguments in a meeting, on duplicate work inside a company, on trade wars between countries. A high I factor means you're wasting a ton of energy. A low I factor means your system is humming along, super efficient. And this one number, as you're about to see, is the key to pretty much everything.
And here is the truly revolutionary part. This friction tax, this I factor, it's not just a measurement, it's a predictor. It can tell you if a system, any system, is on a path to growth and stability or if it's heading for decline and total collapse. It's a universal law that seems to apply to everything, from a single cell to an entire civilization.
So this is it. This is the magic number 1. When that I factor is greater than 1, a system is deep in the red zone. It's literally burning more energy on conflict than it's creating in value. That's a one-way ticket to disaster. But when the I factor drops below 1, something incredible happens. The system flips into a cooperative state. It's not a slow, gradual thing. It's a sudden shift, like water freezing into ice. And in that new state, the system becomes wildly efficient and incredibly resilient.
And the payoff for crossing that line, it's just mind-boggling. When biological systems make that switch to cooperation, think about bees and flowers or those fungal networks again, they become 100 to 1,000 times more energy efficient. That isn't a tiny improvement. That's a massive, game-changing evolutionary leap. It's the difference between just barely surviving and absolutely thriving. So if this is a universal law, then it should be possible to map it out, right? To create a kind of a GPS for cooperation that shows any system how to get from that red zone of conflict into the green zone of collaboration. Well, it turns out that map exists.
It's pretty amazing, but this entire dynamic for any system at any scale can be visualized on one single chart, a phase space that maps the universal journey from conflict to harmony. And we're about to see what it looks like. Okay, let's break this down because it's the heart of the whole idea. On the bottom axis, you've got perpetuity. That's basically just how long a system has been around, how mature it is. On the vertical axis, compatibility, which is how much the environment supports cooperation. Now, every system starts out in that bottom left corner, in the red zone of pure competition. But over time, as systems mature and their environment gets more stable, they all naturally crawl towards the top right, crossing that critical I factor threshold into the green and blue zones of cooperation. This map, it basically shows the inevitable direction of evolution. Now, I know this might look like some abstract model for biology, but the I factor is a universal metric. You can apply it to literally anything: forests, financial markets, software development, you name it. Let's look at a few real-world examples to see how this actually plays out. Let's go back to that forest. When trees plug into that fungal network, they're not just getting some extra food, they're slashing their friction tax. By working together, they dramatically lower their competitive I factor. And what's the result? A massive 100 to 1,000-fold increase in their ability to get resources. It is a perfect, beautiful example of how cooperation literally creates abundance out of thin air. And you can see the exact same logic in the world of technology. Think about a proprietary software model. It's built on secrets and locking customers in. That's a system with a high I factor. It's designed for competition. But an open source project like Linux, that's a model of deep cooperation. Its I factor is actually negative, which means every new person who joins actually adds more value than they consume. And the result? A thriving, unbelievably resilient system that has run circles around its closed-source competitors in so many areas. And then you have the other extreme, the ultimate high I factor system: global military conflict. Those trillions of dollars spent every year on weapons and warfare, that is a direct measurement of the energy our species wastes on competition. From a purely mathematical, thermodynamic point of view, it's one of the most inefficient things we could possibly do with our resources. But even in that world, there is this incredible example of the alternative: the International Space Station. It's a system of deep, deep cooperation between nations that, not too long ago, were sworn enemies. By working together, they protect a shared $150 billion piece of infrastructure. And when major emergencies have happened, they've solved them together, for a tiny fraction of that cost. It's just a powerful reminder that even the most competitive systems can cross that threshold. And all of this brings us to what might be the most profound part of this whole idea. Because unlike trees or animals, who are kind of stuck on the slow path of evolution, humanity has a superpower: consciousness. We can actually understand these mathematical laws and choose to act on them. The model even has a variable for this. It's called epsilon, the consciousness acceleration factor. It represents our unique ability to see the map, understand the math, and consciously decide to build systems, our laws, our institutions, our technologies that are designed for cooperation from the very beginning. It's our ability to hack the evolutionary process itself. Just look at this timeline. It shows you the insane power of that choice. Natural evolution might take thousands of years to favor less aggressive traits in some species. But humanity? We can invent and roll out a system of laws, a form of institutionalized cooperation, in just a few centuries, maybe even decades. That's an acceleration of 10 to 100 times. We can literally put our foot on the gas and speed up our journey towards a more cooperative world. So what this really all means is that, as far as we know, we are the first species on this planet to be handed the blueprint. We don't have to just drift along passively. We can actually look at the map, see where we are, and consciously chart a course toward a more cooperative, more efficient, and more stable future. So in the end, it leaves us with a choice, a really big one. The math is clear. It shows us the path. It shows that a more stable, prosperous, and sustainable future is built on cooperation. The question isn't, is it possible anymore? The laws of thermodynamics say it is. The real question is, will we use our unique gift of consciousness to deliberately design that future? Or will we just let the unforgiving math of conflict decide our fate for us? The choice, for the first time ever, is ours.